Hey everyone, and welcome to this explainer. Today, we are going to completely shatter the illusion of the magic AI box. We so often think of artificial intelligence as this static, finished product, right? Like you type in a prompt, hit enter, and it magically spits out an answer. But today, we're diving into how these systems actually learn, adapt, and evolve over time through a really fascinating discipline called loop engineering. Basically, it's the practice of designing these continuous feedback loops that allow AI systems to constantly refine and improve their outputs.
To really wrap our heads around this, let's look at a pretty sharp contrast. Think about traditional software. It operates in a super straight line. It takes an input, processes it, and gives you an output. Boom, done. Its behavior literally does not change unless human developers go in and manually rewrite the code. But modern AI, it is an entirely different beast. It functions much more like a living, breathing system. It constantly cycles through output, evaluation, feedback, and improvement. It doesn't just blindly execute commands, it metabolizes information to survive and get just a little bit better at its job with every single interaction.
So moving into our first major area, AI as a living system, going from static models to continuous evolution. To really grasp how we got to this point, let's take a quick look at the history of these mechanisms.
The concept of a feedback loop isn't exactly new. Back in the 1950s, early engineers used basic feedback loops just to regulate things like temperature and pressure in industrial systems. Fast forward to the 90s and 2010s, and we had machine learning and deep learning models that were getting pretty good at recognizing complex patterns. But those systems still mostly sat there statically after they were deployed. You had to do these massive periodic retrainings with manually curated datasets. But then, look at the 2020s. Today's foundation models are generating text, code, and decisions in real time for millions of users at once. That sheer scale, it absolutely demands continuous, real-time evaluation. They just can't wait for a manual update. They literally have to learn on the fly.
Which brings us to the anatomy of the loop itself, the 6 stages of AI evolution. So, how does this real-time learning actually happen under the hood?
Let's break down the exact metabolic cycle that keeps an AI system alive and kicking. It all kicks off with data collection, pulling from users, sensors, or databases. Then comes processing and inference, which is just the model making a prediction. Step 3 is output generation, like a chatbot finally replying to your message. But the real magic? That happens in steps 4, 5, and 6. That output is evaluated. Feedback is collected, maybe from your 5-star rating or an automated validator. And finally, improvement occurs through prompt refinement or model fine-tuning. The big takeaway here is that every single iteration provides brand new information to make the very next output exponentially better.
Now, stepping into our next section, the human element, or the guardians of the loop. Because let's be honest, an AI definitely cannot evaluate itself perfectly all the time.
Enter the concept of human in the loop, or HITL for short. Instead of just letting the AI make every single decision completely unchecked, humans actually step in to participate in the learning process. By placing a human in the loop, we directly intervene in that cycle we just talked about. Imagine an AI customer support bot giving a wildly inaccurate response to a really frustrated user. A human agent can review that mess, correct it, and immediately feed that correction right back into the system. That single human interaction is incredibly valuable training data for the AI's next interaction.
And look, this human oversight is absolutely essential. We literally rely on humans to reduce those weird AI hallucinations and handle highly ambiguous situations that machines just totally fail at. This is a massive deal in high-stakes domains like healthcare, law, or finance. In those fields, we absolutely must spot biases and ensure strict regulatory compliance before the AI adapts its behavior. The human is basically the ultimate safety valve in the loop.
Okay, so let's see how this builds into something a bit more automated. Reinforcement learning. Think of this like training a dog. An AI agent interacts with its environment and gets rewards or penalties based on its actions, trying to maximize its long-term success. But when we combine this automated process with the human element we just discussed, we get RLHF, reinforcement learning from human feedback. We use our human preferences to reward the AI, basically guiding its behavior so its outputs perfectly align with our human expectations and our organizational values.
All right, let's level up, moving to advanced AI loops, agents, reflection, and RAG, because modern AI is getting incredibly autonomous.
See, modern AI isn't just about those simple, single-turn conversations anymore. It's all about agents. In an agentic loop, the AI actually understands a complex objective, plans out a whole sequence of actions, and starts executing them.
But the absolute game changer is in the final steps: evaluate and self-critique. Modern agentic AI uses these reflection loops to actually critique its own work. It literally pauses, reviews its own output for accuracy, and fixes its mistakes before it ever shows the final result to you. And when you pair that kind of autonomy with RAG, which stands for Retrieval Augmented Generation, the system gets exponentially smarter. Foundation models have vast general knowledge, sure, but they definitely don't know your company's specific up-to-date HR policies. A RAG loop adds a retrieval step right before generation. It searches trusted, highly specific knowledge sources first, evaluates relevance, and then generates the answer. Over time, the AI learns to continuously update its search strategies to pull the most current and verifiable data possible. It heavily reduces the chances of the AI just making things up.
So, moving on to the real-world impact. Seeing these loops in action across industries. Because you might be wondering, why does all this engineering actually matter to you and your business right now?
Well, loop engineering is literally the foundation of the intelligent systems we use everywhere today. In healthcare, clinical feedback from actual doctors is continuously refining AI decision support systems to give more accurate diagnoses. In finance, banks are using these exact loops to adapt to incredibly fast evolving fraud patterns. So as criminals change their tactics, the AI instantly adapts to catch them. In e-commerce, every single time you browse or rate a product, a loop is quietly refining your personalized recommendations. It even extends to the physical world. Think about an autonomous vehicle learning continuously from messy real-world driving conditions to improve its navigation.
Which leads us to our final section: challenges and future frontiers. How do we actually build better loops? Because keeping these complex, biological-like systems healthy is definitely not a walk in the park.
Organizations are facing some massive hurdles here. Sure, human review is great, but man, it is expensive and incredibly time-consuming. Plus, human feedback can sometimes just be straight up inconsistent or biased. Then you have the staggering computational cost of continuously retraining these massive models. And because these systems are constantly gobbling up data to learn, organizations have to navigate a minefield of strict privacy regulations. On top of all that, if you aren't monitoring the loop carefully, you can suffer from model drift, where the AI's performance actually gets worse over time because the real-world data it's consuming is shifted.
So, to overcome all these headaches, organizations rely on disciplined engineering practices, specifically MLOps, or machine learning operations. MLOps is all about automating these pipelines. By defining crystal-clear success metrics, setting up secure data governance, and designing modular architectures, these models can continuously improve safely as new data rolls in. You don't have to completely tear down and manually retrain the model every few months. A solid MLOps pipeline manages that continuous evolution securely and efficiently.
So look into the future. With the massive explosion of large language models, generative AI, and enterprise applications, the whole paradigm is shifting. Success in AI isn't going to depend solely on who has the biggest datasets or the most ridiculous hardware. The real winners will be the ones who engineer the best loops. We are rapidly moving towards self-improving AI systems that can automatically identify their own blind spots, generate their own synthetic training data, and optimize their workflows, all while operating safely under human-defined constraints.
Which leaves us with a pretty provocative final thought to chew on. We've seen today that AI is absolutely no longer a static tool. It's a continuously evolving system. So the really crucial question is this: if AI is simply a living reflection of the feedback loops that we interact with and design, what exactly are we teaching it today? Thank you so much for joining me on this explainer, and I really hope this changes how you view the intelligent systems you interact with every single day.